So these are our Tuaka actuators that we received the Hermes Award for last year. We have not only a product here, it's a product portfolio. So we are starting with the Tuaka Active, where we have the gearbox and the motor only. And this is the version Servo, where it comes with the encoder. In that case, we added our special feature, which is the inner pipe protection. Similar like this. We also have this for the Tuaka Drive version, so you can put it inside, and if the wires are guided through the hollow shaft, they are protected from high-speed rotational parts. And in this actuator it's maybe not so important because we are having the low-speed shaft inside. It also carries the second encoder. While in this unit it's very important because the high-speed shaft is rotating with up to 4000 RPM. So the inner protection for the wires does give a significant benefit to the customer, and for both the solutions we offer that as an additional feature. So with this portfolio the customer can exactly select what he needs for his specific problem, and with the basic options and the accessories he can really configure a solution that is ideally suitable for the application. This is one reason why we received the Hermes Award, because it's well thought through, it's very flexible, the customer can choose whatever he needs. And additionally, we have one very special feature, which is the integrated torque sensor that we are showing here in the demo. In this demonstration, we have a hand guiding mode that you can set on here with the connector, with the plug. So when I press it, I can move the joint based on the torque signal that I'm receiving. When I remove it, then it's as stiff as it should be. So we can select the different joints here, which is a GUI that we just made for trade fair purpose. And you can see that it's super easy to remove to guide the robot with just one finger. Additionally, we have another demo feature that is called impedance mode. This is a feature that you have in a modern robot. So now I have a spring behavior, so I'm putting it to the position and then it goes back. I can adjust the spring behavior here, so now it's more stiff. Now I need more force to control it. At the end now it's not precisely controlled because this is not implemented in the GUI, but we could imagine that the robot goes to the exact position that he should be and does his job. And while being in the impedance mode, if I'm a human, I can touch it and he will go back to the position. So this is depending on how the customer uses his PLC and the control behind it. But the feature is that you can make a soft and smooth robot with the torque sensors that are detecting the torque and applying another dimension of control theory. So again, this is the hand guiding mode with all joints now active, so I can set, move, manipulate the robot wherever I want it to be. We also implemented soft end stops, so when I'm now doing high force, now he's in emergency, because we implemented that as another safety protection feature. We don't want to hit the table, so it was going into the safety before we are hitting the table. Now I'm going to release it. I have to switch it on again because this is a safety related feature. Then I will reactivate the hand guiding and then I can do it all over again. And again, if I'm going outside the boundary condition, here in the safety condition, the robot is parked and he cannot harm any people. The last thing that we can see here today is the torque signals themselves. So here we have a scope of the 3 different joint torque sensors, and when I'm touching here I can see spikes in the scope, which is the torque information that I'm getting when I'm just in interacting with the robot. So here you can see joint number 2, for instance. You can hold it, you can move it, and we can see exactly that pattern in the signal that is provided on the EtherCAT and can be used by the customer for any application feature. Basically, that's the main content of the demonstration and the product. For anything more, ask questions.